our study of functions this year, we're going to begin with just the basic notion of what a function is and kind of how it operates. We're going to look, hopefully, at a little simple, silly example, and maybe understand a little more clearly what is meant by the words domain and range and how they affect the problem. So we'll start off here. Well, let's start off with that definition. A function can be described as a machine that produces an output that depends. There's that word depends, which is what we're going to focus on in this study. So the output depends on what is put into the machine. So our first silly example is it's going to be a movie title machine. And in this machine, we're going to input the name of a movie, and the output will be the first letter of that movie title. So here, let me see our input here. We're going to input our title into the machine, and it's going to output only the first letter. So if we put in Green Lantern, first letter is G, so the output is G. Spider-Man is going to output S. 101 Dalmatians, what's in front? We don't know. So I can't output anything for that. Batman Returns, that's a B. The input, what goes into the machine, is the domain. So that's the domain. And notice in this problem up above that when 101 Dalmatians, when we attempted to put it in, it rejected it because it didn't know what to do with it, because it didn't have a letter in the front. So the 101 Dalmatians is not in the domain because it would break the machine if we try to put it in. So the output, what comes out of it, is also known as the range. So those are two terms, vocabulary words, that you need to know. So elements of the range, elements of the domain are Green Lantern, Spider-Man, Batman. We couldn't put the 101 in there for that. So Green Lantern, Spider-Man, Batman. And what got output were the first letters of that, which were G, S, and B. So those are all elements of the range. For the movie machine, the domain is, and then we put little brackets here and say Green Lantern, Spider-Man, Batman, and ended up. And the range were those first letters, and we put them again in the brackets, would be G, comma, S, comma, B. This next rule is something that's more algebraic, something that fits more into our class. The output is going to be one less than 2 times the input. And often for input, we'll use just the variable x. So I'm going to input an x. I'm going to input something into it, some number into it, and I'm going to have in 1 less than 2 times whatever I input. So that's going to be my rule, 2x subtract 1. And then the output is what comes out. So if we input, say, for example, let's say we put in a 5. If I put in a 5, I'd have 2 times 5 is 10. 10 minus 1 is 9. And a 9 would be the output. If I put in, let's put in a negative this time. So let's say we put in a negative 3. That's going to give me negative 6 minus 1. And that gives me a negative 7. So if we put in, say, let's try a 0 with 0 works, of course it does. Let's put in a fraction, 1/2. So 2 times 1/2 is 1, and 1 minus 1 is 0. So what numbers can be put in the machine? Well, we put a positive, so I think any positive would probably work. We put in a negative. I think any negative would work. We put in a fraction. Looks like fractions would work as well. So we could put in anything. So really for the domain, it was any number. So any number. So we could express that, all real numbers with that R. What numbers came out of the machine? Well, let's see, we can output it a 9, a negative, a 0, and could we output a fraction? Yeah, so it says, for example, maybe we put in a 1/4, it's going to end up with a fraction answer. So it looks like for the range, everything came out as well. So all numbers as well. So we could put an R for that. So so for the domain, it was all numbers. So I could put anything into the machine I wanted to, anything, and it would shoot out any number. You know, there's all kinds of numbers that will come out. There were no restrictions on what came out of that machine as well. All right. So our next one, this rule is square it. So our input, the x that comes in, is going to fall in, and then we're going to raise it to the second power. All right, so let's try kind of the same thing. Let's choose, say, a 3, a positive number. So 3 squared, the output that comes out of the machine would be a 9. Let's try a negative, so we put in a -2. So -2 times -2 is going to put out a +4. What about a 0? 0 times 0 is 0. And let's do one more. Let's say we put in a 1/2. If I put a 1/2, I get 1/2 times 1/2 is 1/4. All right, so domain. Let's say we put in positive numbers. We put in negative numbers. We put in a 0. We put in a fraction. They all worked. We got an answer for all of them. So because we got an answer for all of them, because there was something that shot out of the machine, that means that they're all in the domain. So again, it appears that all real numbers are in our domain. So how about the range? Put in 3, we got 9. Put in -2, we got 4. 0 got 0. 1/2, we got 1/4. Let's look. What's missing here? We're missing a negative output. So it appears that anything that we put in is going to shoot out a positive number. Oh, except for 0. 0 shot out as 0. So for our range, the description could be all positive numbers plus 0. And so we could say that by saying that x, the x that not x, we say that, we'll just say it's all positive numbers, 0. So output's y, so we're going to say that y has got to be greater than, it's going to end up being greater than or equal to 0. We don't have any choice what happens, it just comes out. So the only numbers that are going to come out are going to be 0 or positive. So we say that the output, which is y, is greater than or equal to 0. Now this next one says take the square root. That's vocabulary, square root, and add 3. So whatever we put in, when the x falls in, is going to take a square root of it, and then it's going to add 3. All right, so let's try some numbers. We could do a lot of numbers with our calculators, but I'm going to choose ones that we can do without calculators. So let's say I put in, again, let's put into that a 9. If I put in the 9, square root of 9 is 3, and 3 plus 3 is 6. So the output is 6. If I put in, let's squeeze this up here, say a -4, again, something I know the square root of. The square root of negative, that won't work. I can't take the square root of a negative number, so no answer is going to come out. And -4, we'll just say it broke our machine. It doesn't work. What about if we put in a 0? We put in a 0, square root of 0 is 0, 0 plus 3 is 3. Question marks there in red. And fraction, put in a fraction like 1, oh, let's do 1/4. Square root of 1/4 is 1/2. Oh, 1/2 plus 3, 3 1/2, so that's 7/2. So 7/2. We get an answer for that. Anything else you want to try? Let's see. So the domain, could I put anything in? Did everything I put in shoot an answer? No. The -4 didn't result in an answer. So in fact, any negative number would not work. So that means that our domain has got to be 0 or positive. So since it's a domain, it's an x, is the number we're putting in. It's got to be greater than or equal to 0. And the range, what came out, let's see, every time we put something in, it's a positive number, and it's going to shoot out a positive number, but it's going to be +3. So it looks like our answers are going to be positive, but can you be more specific? I think the smallest number we can put in is a 0 right here. Smallest number is a 0. And when I put in a 0, I get +3. I end up with a 3. So it's not possible to get anything smaller than a 3. So our range this time is going to start at 3 and get bigger. So we're going to say that y is greater than or equal to 3. The range is y. 3 is the smallest number that it can be. Stop that. So again, we want to say that functions express the dependence, there's that word depend again, of one measure on another. It depends what we put into our machine that is going to go through the rule and an answer is going to come out. If we put something different in, a different answer is going to come out. So it depends what we put in, the result that we get. So f depends on x is written this way. F of x. So f depends on x, and we read it not f depends on x, but f of x. So notice that this is not multiplication. Now that is not multiply. So a lot of times when you're reading, you read by context. So if you're talking about functions, and pretty much anytime you see an F, that means that you're talking about a function. If you're talking about functions, when you see the F with a parentheses x, it does not mean F times x. It means F of x, and it means a function named F that you're going to plug x into. Example 1, express each relationship using function notation. If the number of bacteria depends on time, we say that's B of T. If the grade G you receive depends on the effort, we call it G of E. So a lot of times when we name functions, we name it with a meaning that matches what we're talking about. So y equals f of x means y is a function of x, or y depends on x. This right here, the numbers that go in here are the numbers in the domain. So the domain goes in for x, and what comes out, oops, that's not showing up again, are the elements in the range. So take something for domain, put it in, outputs range. All right, just a real quick review. If g of x is equal to 3x minus 2, fine. So 3x minus 2 is our rule. That's our rule. The name of it is g of x. So that says, when it says g of 2, that means that I'm going to take the -2 and I'm going to plug it in to my rule. So when I do that, that's going to give me negative 2 minus 2. So that's negative 6 minus 2 is negative 8. So G of negative 2 equals negative 8. G of 0 says that I'm going to take 0, 0 is my x, I'm going to plug it in to my rule. So I'm going to have 3 times 0 minus 2. 0 minus 2 is negative 2. So G of 0 equals negative 2. So G of m, this time I'm going to put m into my rule. So that would look like 3 times m minus 2. So G of m equals 3 times m minus 2. If f of x is equal to x squared minus 1, again, this is my new rule. That was a G rule. Notice that rule up there was named G. This rule is going to be named f. So f of x is equal to x squared, subtract 1. So when I see the f, I go to the f rule right there. So those are going to match. I'm going to put the negative 3 into my rule, which is x squared minus 1. So f of negative 3 is going to be equal to negative 3 squared minus 1. That's 9 minus 1, and that's 8. So f of negative 3 equals 8. 0, I'm going to plug, oh, notice we switched here, didn't we? This time it says G of 0. I bet that was a mistake. Let's change these to f's. I'm going to change both of these to f's right there. So f of 0, I'm going to go to this, again, the f function, and plug the 0 in. So I'm going to get 0 squared minus 1. That's 0 minus 1. So f of 0 is equal to negative 1. F of a minus 2, again, go to the f function. And where I see the x, I'm going to put in this whole input. So my input this time is the whole thing, a minus 2, that binomial. It's going to get squared, and then I'm going to subtract 1. So my input's a little more complicated this time. This is a binomial squared, so that's going to be a minus 2 times a minus 2 minus 1. So this multiplies to be a squared minus 2a minus 2a plus 4 minus 1. And simplify, vocabulary word, simplify, that gives me a squared minus 4a plus 3. So f of a minus 2 is equal to a squared minus 4a plus 3. And our last example, this time we have an h function. So we'll plug our input into the new h function here. That matches the h and h. I'm going to take negative 1 and put it in, so that gives me negative 1 over negative 1 minus 2. So negative 1 over a negative 3. And that ends up being 1/3. So h of negative 1 is equal to a positive 1/3. H of 0 is going to give me 0 over 0 minus 2. That's going to be 0 over negative 2. And that simplifies, there's that word, h of 0 is 0. And finally, if we put in a 2, we get 2 over 2 minus 2, 2 over 0. Division by 0 is undefined. So that means when I put in a 2, it kicked it out and didn't give us an answer. So we'd say that 2 is not in the domain of